Good morning and welcome to the second lecture of logic and propositions. Uh, in first lecture we had some logical connectives. Now these connected these connectives are continued. Next is implication. Implication, that means conditional statement. It is P implies Q. It means if P then Q. Means if P is a condition, then Q must be the conclusion. Where P and Q are propositions, P implies Q is false when P is true and Q is false. Then only P implies Q is false, otherwise it is true. As you can see in the left hand side, the truth table of P implies Q. In P implies Q, P is called hypothesis and Q is called conclusion. Fine. And there are several other notations for or you can say terminology for P implies Q, which is P implies Q, P is sufficient for Q, Q if P, Q is necessary for P, P only if Q, Q follows from P. These are few conditions. You can say these are the few terminology which will be used. Fine. So next, it is there is some example or for P implies Q. Example: if P is it is sunny today, Q is we shall go to the beach. Then P implies Q will be if it is sunny today, then we will go to the beach. This implication is true unless it is indeed sunny today, but we do not go to the beach. Means P implies Q is false. As you can say, it is P implies Q is false when P is true and Q is false. So that you can say we do not go to the beach. So this is Q is false. Hence P implies Q is false. Fine. Again, in this case, there is some relation between hypothesis and conclusion. Fine. Now, again, one more example. P is f is a fx is a differentiable function. Q fx is continuous function. P implies Q. If fx is differentiable function, then it is continuous. So this is P implies Q. Now there are several other implications related to P implies Q. These are very important thing: converse, contrapositive, and inverse. So converse, what we can say, if P implies Q is implication, then Q implies P will be called converse. You can see Q implies P. Again, contrapositive of P implies Q is negation Q implies negation P, and inverse is negation P implies negation Q. Third one. Fine. So these three are very important things and you must know this. Fine. Next we can say the truth table of all these things, and you can interpret these things. Look, you can interpret these things that in truth table P implies Q is already we know. Q implies P. Q implies P means this is converse of what? P implies Q. So that you can say converse when P implies Q is true, it is also true. Difference is where when it is false, it is true, it is true, it is false. So this is difference between implication and converse. Now the inverse. Inverse, again you can see this is inverse, and again contrapositive is this one. Fine. So this is truth table of these three implication along with P implies Q. Fine. Now Next, one example is given for these three: converse, inverse, and contrapositive. P, it is raining. Q, the home team wins. So P implies Q, it is raining, then home team wins. Converse of this is Q implies P. If the home team wins, then it is raining. Contrapositive, negation Q. Negation Q comes first. Then if the home team does not win, then it is not raining. And inverse, you can try yourself. Similarly, means negation P implies negation Q, means if it is not raining, then the home team does not win. That will be the inverse of this. Fine. Now the biconditional statement. Biconditional means you are dealing with both sides. P if and only if Q, or P implies and is implied by Q is biconditional statement. It is called P if and only if Q. It is true when P and Q have same truth values. You can see in the left hand side truth value. When truth P and Q are true, P and Q are true, then it is true. Similarly, if both are false, again it is true. So that if P and Q have same truth values, then it is true, otherwise it is false. Fine. So other terminology is P is necessary and sufficient for Q. If P, then Q, and conversely P if and only if Q. These are few notations, or you can say other languages you can use with P if and only if Q. One example is given. You can take the flight P, and Q is you buy a ticket. If and only if the biconditional statement of these two is you can take the flight if and only if you can buy a ticket. So this is one example for biconditional statement. Now the precedence of logical operators. Precedence means how you can use these operators. We have done negation, disjunction, conjunction, implies, and finally the biconditional statement, that is implies and is implied by. So that these five operators, how can you use the precedences? First is negation, second is conjunction, third is disjunction, fourth is implies, and fifth is biconditional. So that in now onwards we are dealing with expressions of logical propositions. Means we will be dealing with several variables P, Q, and R, and expressions related to these variables. So a few two example are given in left hand side. P, disjunction, Q, conjunction, negation R is actually how it is read. So operator number one is in precedence order is negation. So that negation is first considered. So that negation is first considered. So that negation will be considered with R. Then conjunction, then disjunction. Conjunction means conjunction will be one thing is negation R, conjunction is secondly considered, and finally disjunction will be considered. So that negation P, disjunction Q, conjunction, negation R is conjunction of P or Q and negation R. So that first negation, then conjunction, then disjunction, then implies, then and biconditional. Again you can see in second example, negation P will be considered first, then implication you can say the fourth number. So that conjunction will be separated. So that it is conjunction of it is implication of negation P and Q, then R. Means negation P and Q will be considered separately, and finally what will be considered? Implication. Fine. So this will be the precedence order of the operators. Fine, thank you.